Depending on where you are, good afternoon, good morning, or good evening to everyone. I'm Peter Bernstein. I'm the Senior Editor of TMCnet.com, and I'll be moderating today's webinar, Secure Analytics in the Modern Data Architecture. I am truly delighted to be joined today by Balaji Ganesan, Senior Director of Enterprise Security and Strategy for Hortonworks, and Sudeep Venkatesh, VP Solutions Architecture, Voltage Security, Inc. Before I introduce Balaji and Sudeep, a little background is in order. There are few topics inside enterprises these days that don't revolve around big data. It's a big topic with really big implications. And as part of that discussion, the hot area surrounds the implementation and use of Apache Hadoop. In just a few short years, this open source framework for distributed storage and processing of large sets of data on commodity hardware has become the gold standard. It should also be noted for context that numerous Apache Software Foundation projects make up the services required by enterprises to deploy, integrate, and work with Hadoop. In fact, the ASF projects are extraordinarily diverse, and each is aimed at enhancement of very specific functions, hence having their own community of developers and timetables. That said, securing Hadoop data is a hot topic in and of itself, and it's for good reason. No matter where you are in your Hadoop implementation plans, it's best to define your data security approach now and not later. Big data, after all, raises big security concerns. There is, or should be, a level of urgency in making sure that your security is up to date. The integration of Hadoop into existing data center technologies and the planned transformation of these data centers in the near future are picking up momentum every day. This means Hadoop and the securing of its data have to be considered now. What Balaji and Sudeep are about to discuss are such things as the need for central policy administration framework across security requirements for things like authentication, authorization, auditing, and data protection, and how data-centric security will remove obstacles to rapid implementation of Hadoop, address privacy regulations, and neutralize data breaches. That last one's a biggie. Also, there will be a discussion about data-centric protection technologies that easily integrate with things like Hive, SQOOP, MapReduce, and other Hadoop interfaces. As the presentation will explain, you can secure data but still make it available for analytics. Before turning this session over to Balaji and Sudeep, I'd like to go over a few administrative details. Both of our presenters will answer questions during a Q&A session that will follow the presentation. I encourage you to submit your questions using the interface on your PC at any time during the presentation when they come to mind, and not just wait until we get to the Q&A. We're going to try to get to as many of your questions as we possibly can, but any that we're unable to cover will be archived, and our presenters will be happy to answer them offline following today's event. As I said, the entire event will be archived, and each of you will be receiving information on how to access it tomorrow in your inbox so you can follow up on anything you missed or pass the information along to colleagues. With that said, we're going to dispense with long-winded introductions and get right to the heart of the matter. Balaji, the floor is all yours.
Thank you so much, Peter. Thank you so much. That was a great introduction. So let me start off. The focus of today's discussion between myself and Sudeep will be on security, but let me start off giving an introduction on Hortonworks and what is happening in Hadoop and why security is becoming a more and more important topic. Just a quick intro on Hortonworks. We were founded in 2011 by quite a few community of developers and committers coming from Yahoo who got together. And our sole focus in Hortonworks is making Hadoop enterprise ready and be applicable for any app or any kind of data. And part of making enterprise ready is working towards building a centralized architecture that has three fundamental services inbuilt around operations, governance, and security. And that's core of the work we do. We work on making Hadoop enterprise ready, right? And so let's start off with Hadoop and then delve into what is happening in the security world, right? So Hadoop, as some of you might be familiar, and as Peter also outlined, the fundamental driver for Hadoop or big data is the explosion in terms of how enterprises are receiving and processing data. There have been analysis done where the sheer data volumes within the traditional enterprises is set to explode to pretty big levels by year 2020. As you mentioned, 40 zettabytes is a big data volume. And there would be, in the enterprise world, the more and more enterprises looking at data as their core unique differentiator and how they can mine the data and present better value to their own customers. Right? What's happening in the traditional IT world is the traditional databases and systems are coming under tremendous pressure because of the sheer volume of the data. They were not built for this to scale with the amount of data that's growing within each industry. The other aspect is the commercial aspect is as the data volume grows, it becomes commercially unfeasible to use some of the traditional systems. And that's where Hadoop enters. And Hadoop came from Yahoo, primarily from Yahoo's own need to build a scalable distributed system which can manage the huge amounts of data Yahoo had. And they started working on this project in 2005 and then contributed the entire technology to Apache Software Foundations. And Hadoop was inbuilt to handle this kind of data problems. And was scalable, distributed architecture, and it can run on commodity servers. And so traditional Hadoop has many advantages. But when Hortonworks started, the big challenge was making Hadoop enterprise ready and making it applicable to any kind of use case, any kind of app and data. And that's the work Hortonworks and the community has done over the last few years. And core part of that is making Hadoop enterprise ready. Core part, as I said, has centralized architecture and having 3 core services around operations, security, and governance applicable across the platform. And security is a fundamental pillar of that, right? And making sure that it's inbuilt into the infrastructure and that can be applied to any kind of use case the enterprise has seen. Right? So what's happening within security, right? And it applies to Hadoop and it applies to Hortonworks as well. And as more and more we are building applications on top of Hadoop, from a security standpoint, enterprises are looking at utilizing Hadoop as a data lake kind of architecture, which means enterprises are looking to put all kinds of data in Hadoop and making sure it can open the platform to different kind of business groups in a true multi-tenant fashion. Okay? What is the real need in security standpoint is how we protect any kind of access point coming into Hadoop, and how do we ensure data can be accessed in a multi-tenant platform and still honor the traditional security policies that protect data visibility and that protect data governance. And more and more the requirements are centralizing around how we can ensure there's consistent and granular security across all the components of Hadoop. How do we ensure there is a comprehensive and a consistent set of policy enforcement across any kind of access point? And more and more as privacy rules are coming into effect, how do we ensure that enterprises are able to retain the privacy controls but still able to infer knowledge from and mine the data? How do we be able to do that? So, and the work, that's where Hortonworks and the community are working towards and making sure how do we inbuild all these security pillars into what we are doing with Hadoop, right? And when I talk about security pillars, there are 5 things that we talk about within Hortonworks. The first aspect is the authentication part, ensuring users and processes are trusted, and that's the step 1 in the security journey. The second aspect is around authorization, is ensuring users have access to, system users or business users have access to only the data they are privileged to. The third aspect is around auditing, ensuring we keep a track of all the user access history and be able to report it for compliance or internal audit purposes. And the fourth aspect is around data protection. How do we protect data when it's at rest and it's being in motion? It's where encryption and data anonymization comes in. And the fifth aspect we think is really important is core to our earlier slide where we talked about centralized architecture, is how we ensure a centralized administration of security, which is tied to existing organizational infrastructure, security infrastructure, so that enterprises can easily manage security as easily they can manage operations or any other aspects. Okay. And within Hortonworks and within HTP, we fundamentally work on all these pillars. We fundamentally also focus a lot on comprehensive security across all these features. So where we stand today within Hortonworks is we offer different Apache projects, and we also work with ecosystem of partners, and Voltage is a strategic security partner with Hortonworks that we work towards to solve the common security problem. And so if you map to the security pillars, in the administration, authorization, and audit, we have Apache Ranger project that has come up over the years. And the background on Apache Ranger is the XA Secure security startup acquisition that Hortonworks did, and we completely open source the technology into Apache Ranger. In the authentication front, we have Apache Knox for perimeter security and native Kerberos. But data protection is an important topic, and it's becoming more and more a core requirement. And as open source, we continue to innovate in there. But that's also where companies like Voltage add a lot of value, right? And it has to be data-centric. So if you view all these pillars, there's a need to ensure that there is data-centric security applied across Hadoop, and it's applied in Hadoop in the context of the organization. It's looked as an organizational strategy. So at that point, I'll quickly summarize where we are. In Hortonworks, the focus is on security and making sure we cover all the 5 pillars of security. And security for us is what we offer is comprehensive and inbuilt into the Hadoop ecosystem. Okay. Just before I hand over to Sudeep, I want to end up on this slide, and that Hortonworks will continue to innovate. And the work we have done so far has been recognized by many analysts, and we have recently appeared in the Forrester Research as the leader in the Forrester Wave about big data Hadoop solutions. We were right at the top. And we'll continue to innovate and grow faster and continue to work on security. Right. So at this point, I think we'll turn it over to Sudeep to talk about data-centric security and how Voltage is innovating in that area. Sudeep?
Thank you so much, Balaji. Thank you for setting a fantastic stage for me to build on. So just very quickly before I jump into the topic for today, a quick introduction to HP Security Voltage. So the company was founded as Voltage Security about 12 years ago, and it pioneered a way to do email encryption so you could protect emails both inside and outside the organization. But since about 2008, the company's also diversified or gone into a second product set called HP Secure Data, which protects sensitive information as it resides in back-end databases, platforms, and systems. And of course, as most of you might be aware, last month HP announced that it was acquiring Voltage Security. So now we will be called going forward, we will be called HP Security Voltage. So certainly, after working for Voltage Security for about 10 years, it is a very proud moment for me and my team as well. So we will be talking about a few different things today. We will be introducing this concept of data-centric security. So Balaji did hint to that a little bit. So of course, security can come at different levels of your stack. Encryption can come at different levels in your IT stack as well. But now, data-centric security or field-level security or application security, call it what you may, is all the rage in the industry. So we'll do a quick refresher about what that is. And then, of course, we will have a look, and as a security company, when we looked at Hadoop, obviously there's a lot of opportunity for us, but Hadoop provides some very unique challenges for a security company in order to secure the ecosystem. So we will look at why historically, obviously there's only a few years of history there, but historically why it's been very, very difficult to secure the Hadoop platform. And then we will look at a few case studies. So there are large customer deployments out there, We'll talk about a telco that's very effectively securing their Hadoop lake using some data-centric security. We will also talk about an insurance company based in the Northeast where I am. I'm based in Boston. So they have some very interesting use cases for Hadoop and are using data-centric security in a very clever way as well. So no technical presentation can end without us talking about how real-life customers are using it. So we will certainly cover that today as well. So securing Hadoop has been notoriously difficult, and there are a few reasons to that. The first one is because the technology by itself is developing very, very quickly. Obviously, there were a lot of investments made in Hadoop and Hadoop companies. A lot of smart folks left companies like Yahoo, Facebook, Google, etc., to found Hadoop companies. So what we're seeing is that the technology is innovating very rapidly with a very well-funded industry as well. So it's been very hard for us security companies to keep up with the Hadoop ecosystem. That's an honest confession. Multiple sources of data coming from different enterprise systems are entering Hadoop at a very rapid pace. So you've certainly heard the buzzword Internet of Things, but we have a customer who is actually doing the Internet of Things. So this is a large motor company, one of the largest motor companies in the world, who's come under some security issues with their cars in the last few years. So what they're doing is that they're putting multiple sensors in their cars, and these sensors are, for about 5 million cars on the road, these sensors are sending 30 units of data per 15 minutes to a central server, which needs to be processed in real time and then provide feedback to the end users. So that is an immense amount of data if you look at the amount of information that's flowing into their Hadoop infrastructure. The other thing is the different types of data elements going into Hadoop. So we have customers putting PCI data like credit card numbers into Hadoop. We have customers putting other sensitive information like social security numbers of their patients, of their employees as well into Hadoop. We work with a large telco that I'll be talking about at the end of the presentation that put things like GPS information and phone number information of their end users. We've got customers taking log information, HTTP click data, putting that into Hadoop as well. And one thing about security, especially about data-centric security, is you really need to know what the data is in order to figure out its value and to protect it. But the problem with Hadoop is that that data is going in a very rapid pace and is also extremely wide and varied. The other thing that makes it very difficult in Hadoop is the fact that there are a number of non-technical people, including data scientists, non-technical from an IT infrastructure perspective, who want to access that Hadoop data. So a large credit card company that we work with has, marketing folks who want to mine HDFS to create new marketing programs for their credit card consumers. And they also have collection agents who are logging into these systems in order to send, people into collections because they've not paid their debts. So the requirements, the security requirements, the data access requirements for these two types of people are very, very different, because obviously a marketing person doesn't need to know the consumer's SSN, probably doesn't need to know the consumer's credit card number as well, but the collections person and the collections report that goes through needs all that data. So there are, just basically to summarize that point, there are a number of different types of users who need access to Hadoop for different analytic needs. And then, of course, one of the things that makes Hadoop very reliable, which is, data is replicated across multiple nodes. So in case some nodes in your cluster goes down, you still have a very good chance of recovering your data. That very fact also makes Hadoop extremely difficult to secure. So, because data automatically gets replicated across multiple nodes in a fashion that is not very clear to the administrators. Of course, that means that your sensitive data now is being replicated across multiple nodes, which presents you with some unique challenges where when you're looking to secure Hadoop. And then obviously, if Hadoop clusters are being used in the cloud, So we've got many customers who are using Elastic MapReduce as it's available with Amazon Web Services. We've got customers who are deploying Hadoop on bare metal in IBM SoftLayer, for example, to get additional performance for their data scientists. So obviously, once that sensitive data leaves your organization and goes into the cloud, several customers are putting production Hadoop deployments in their own four walls, but then doing test and QA in the cloud. So once you start moving sensitive data into the cloud, then obviously that changes the game in terms of how you can secure it as well. So how have companies reacted to this, right? Obviously, Hadoop is a new technology. It's a little concerning from a security perspective for CISOs and security directors. So companies have reacted to it in two ways to start with. The first way is that whatever existing IT security mechanisms you have in terms of firewalls, in terms of network segmentation, in terms of logging monitoring, in terms of configuration management, some DevOps configuration management that you might have with Puppet and Chef, they're being applied to the Hadoop ecosystem as well. Right, so make sure that your Hadoop data lake is well firewalled. Make sure that folks need proper authentication and authorization before they can even get to the Hadoop networks. So these are the basic things that organizations are doing when it comes to protecting their Hadoop infrastructure. On top of that, of course, and Balaji again was mentioning a couple of different projects here. He mentioned Apache Ranger, where you can have a common policy across your Hadoop cluster and Hadoop deployments. And then Apache Ranger also helps you with collecting different audit logs and making sense of it. And then Balaji also alluded a little bit to Apache Knox, which does more perimeter-based security. So, you're properly authenticated and authorized before you can run access your Hadoop clusters and run queries in it. So, of course, the Hadoop community has paid attention to some of these security requirements and has introduced some native projects in terms of Knox and Ranger that can help you here as well. But what we're looking at sort of a third wave in terms of security mechanisms, where the security is of course you have perimeter security and you have your logging and monitoring, but security is also moving closer to the data, and that is what we'll see in terms of a data-centric security model. So taking a little bit of a pause and changing directions, most of you, I assume, on the call are very technical, or at least have a little bit of a technical background, and you will immediately recognize the OSI stack that you're seeing in front of you. Now, when you talk about encryption as a way to protect data or to protect systems, the power or the use that you get of encryption solely depends on where in your stack, where in the stack that you're seeing on your screen that you deploy encryption on. So, for example, you can deploy encryption at the lowest level, at the storage level. There are many companies that provide these solutions. Linux, for example, has the dmcrypt solution that you could use here. But the only protection that it gives you is against someone walking into the data center and stealing the hardware or stealing the appliance. Similarly, you can rise higher up in the stack, and I'll use an RDBMS example. You can have things like TDE or transparent data encryption of your columns. But again, as the TDE manuals very well say, the only protection that it gives you is against someone stealing your hardware again and against loss of backup files. And then you could also have TLS protocols, which protect you from a point-to-point perspective in networks. But again, that only protects you against someone sniffing the actual network. So what we mean by data-centric security is moving security to the highest point in your stack, where you're protecting the actual data at the field level or at the application level. So it doesn't matter how that data moves up and down your stack, it is still protected. It doesn't matter if that data moves from node to node or from application to application, it is still protected. So this concept of data-centric security is what we're seeing more and more, not only in the RDBMS world, the data warehousing world, but also in Hadoop. So we will look at a couple of core technologies that have enamored customers there in the industry today. The first technology that I wanted to talk about is a technology called Format-Preserving Encryption. And typically when you think about encryption, so typically if you think about taking Peter's SSN and encrypting it, you think of it encrypting into this large piece of garbage. Now that large piece of garbage causes you some very practical problems when it comes to operating in your environment. For example, now all your applications which were accepting 9 variable characters for SSNs, or all your database schemas that were cached to accept a 9-character integer now have to change because they have to accommodate this new piece of garbage. But what you can do with format-preserving encryption is that you can take something like a social security number or a name or an address or a credit card number, and you can encrypt it such that the resultant output has the same format as the input. So what this immediately means from a business perspective is that the vast majority of applications that do not need the real SSN, but can just operate on a predictable, with a key, just on a predictable nine-digit output, now can stay unchanged. This also means that you're using encryption to protect your data in rest, in storage, and in use. So for example, the vast number of Hadoop queries that you might be running or analysis that you might be doing on Hadoop might not need the real SSN. If they're counting or if they're, sorting or indexing, they can keep operating on the protected SSN or an SSN that's format preserved and encrypted. So that's the first business value. Some other properties here include the fact that referential integrity is preserved. So what this means is that if you were using the same key and encrypting an SSN on Teradata, then you would get the same value with the same key on Hadoop as well. So that way, again, your searches, index, joins, counts, etc. would turn out to be the same. The other thing that we're seeing with format-preserving encryption is that not only is this a good tool to protect production Hadoop environments or production IT environments, but it's also an excellent way to generate test, masking, and QA data. So format-preserving encryption is one way in which you can take security as close to the data as possible and still have the ability to use it in its encrypted or protected form. So that's just one technology that's available in the industry today. Now remember that there are many organizations out there who provide format-preserving encryption, but as a user of encryption technologies, you should pick technologies that have been standardized or have been through the standardization process. So the format-preserving encryption that HP Security Voltage provides has been going through the NIST standardization process for quite a few years. So right now this technology is available as a NIST draft standard, and we're hoping that in a short amount of time, this would be a full-blown NIST standard as well. So make sure that you understand that not all format-preserving encryption is the same. The more open the technology is, the more peer-reviewed it is, and more standardized it is, the lesser the risk is for you and your organization. Now, apart from format-preserving encryption, however, there is also a technology called tokenization that we provide. And while format-preserving encryption creates an association of data in the clear and protected data with a key, with tokenization, you're actually using a random lookup table in the backend to do this association. So tokenization is more used for the PCI use case when you need to take your Hadoop system out of PCI scope. So many companies provide technologies that can provide PCI compliance of your Hadoop ecosystem, but isn't the best outcome if you don't even have to do that, if you can take your entire Hadoop system out of PCI audit scope. And tokenization is one great way to do that. Now, stateless tokenization is a process where instead of using a large and growing database, which has problems with scale, with disaster recovery, and with replication, you can pretty much perform tokenization using a smaller random mapping table. So now instead of managing a large database of tokens, you just have a much smaller table which can be replicated very, very easily there. So let me just go back to my slide. So even with tokenization, the format of the token can be determined based on what your business process is. So many times we see customers who are leaving the first 6 digits of a credit card number in the clear. So that way this credit card number can be routed very effectively, and also leave the last 4 in the clear in case you need it for customer support requirements. Another format for doing tokenization is where we can take the middle few digits and we can convert them into alphabets. So if you have an auditor or if you have a security team member who's logging into your Hadoop ecosystem and doing a scan or a search, all they will see is protected data in that regard. So I'm a very visual person, so this slide always helps me have a look to understand how these core technologies work. So the data in red, as you can see, is data in the clear, while data in the green table is what is format preserved and protected. So as you can see, everything from names to social security numbers to driver's license or customer ID fields have been encrypted or tokenized, and their format is exactly the same as the input data. Now, with some things like social security numbers, it might be worth your while to just encrypt the first 5 digits and leave the last 4 in the clear. So what this means is that any business process or any querying that you're doing that only needs the last 4 digits of a social security number now doesn't have to decrypt that data or doesn't have to detokenize it either. So what we're seeing more and more, and we'll look at a few architectures in the few coming slides, what we're seeing more and more is a push to encrypt or tokenize this data from a field level before putting it into Hadoop. So we will spend a little bit of time looking at those architectures. Of course, we know when you talk about encryption or when you talk about tokenization, you also have a requirement for policy management and key management. So just very quickly from a product perspective before we get into the architecture and customer stories, Voltage also provides a stateless key management product or a key management solution. So what this again means is that instead of having a large growing database of keys that have to be stored, that have to be managed, secured, and replicated, the HP Voltage solution can generate keys on the fly as and when required using a key derivation function. So again, there's a lot of useful information on our website on www.voltage.com. Go to technologies, go to stateless key management, and that will give you a lot of information on some of the core technologies here. So when we talk about Hadoop architectures, we essentially talk about a 7-step process, and I'll take you through this very, very quickly. So as you can see in the middle, the little rectangle in the middle is HDFS. HDFS with all its storage and all its glory, with all its different tools as well. Now, one option to have data-centric protection in your HDFS is to have that data-centric encryption or tokenization happen on upstream systems. So that is option 1. So this is where you're pulling data elements from Oracle or DB2 or ZOS or your Teradata infrastructure, and that data is already protected from a field level. Then you don't need to change a thing. You just pull data from those sources using whatever tools you have, and you put them into HDFS, and now you have that protection in motion and in use as well. So that's option number 1. Option number 2 is where you can use Option number 2 is where you can use native Hadoop tools to do that protection a little bit. So what you can do, for example, is that when you're pulling data from these source systems, you can use ETL tools like Informatica, or you can land this data on a landing zone. So what we're seeing with many customers is that they're not pulling data directly into Hadoop, but they're storing it temporarily on a landing zone to make some sense of it, to structure that data properly before putting it into Hadoop, to normalize it as well. So that is a good place where, again, as option 2 says, you can use certain tools like command line tools, scripts, and APIs to format, preserve, and encrypt or tokenize that data before it goes into Hadoop. The third point covers a trend that we're seeing more and more in the industry, where we're seeing native integration using APIs into different Hadoop tools themselves. So for example, we have customers who have very custom and fine-tuned MapReduce jobs that are pulling data from different sources and propagating them through Hadoop. In that case, they can integrate with APIs to encrypt or tokenize that data. Similarly, you have Hadoop tools like Scoop, which can go into backend databases, pull data elements out, And in that case, again, they can make API calls to tokenization tools, to encryption tools to protect them before sending them into HDFS as well. So, step 1, 2, and 3 essentially talk about ingestion. Now, ingestion is only one part of Hadoop, right? I mean, you're using Hadoop at the end of the day, so you can do some data processing and you can run some queries on those tools. But what we're seeing more and more, and I spoke to a customer just last week where they're saying that up to 95% of their querying and analysis can happen on protected data. Now, in that case, if you don't need to decrypt the data, or if you don't need to detokenize it, then as you can see in number 4, you can just keep using that data in its protected form. However, if there is a requirement, as you see in number 5, to unprotect that data, so suppose you want to decrypt or detokenize 10,000 social security numbers after you run a query in Hadoop to send them to collections, then again, there are tools that integrate with things like Hive UDFs, where they provide persistent UDFs to do the decryption, or you can also have integration with some of your custom MapReduce jobs. So after the reduction happens in your query process, you can integrate that with Voltage or an API tool to do that decryption. People, however, want to keep pushing the boundary as much further to the right as much as they can. So what you're seeing with option 6 is that you're running your query and you're doing your reduction on protected data. You're then taking that data out either into a business intelligence tool or a flat file, and you're doing the decryption or detokenization completely out of Hadoop. Now, this would depend on what your business use cases are and what your security requirements are. So, for example, if you want to keep HDFS completely out of PCI audit scope, then a good way for you would be to take the tokens out of HDFS and do your detokenization at your BI layer or even in something like a reporting layer or a flat file, right? So that has some very interesting security and regulatory compliance fields there. And the number 7 is a bit of a change in topic. Now, Linux supports this technology called dencrypt, which can do volume level protection or can do storage level protection of Hadoop nodes. So Hadoop by itself is deployed, many times in hundreds of different nodes, or more and more now in thousands of different nodes. So customers are also enabling storage level encryption using either dencrypt or using some newer Hadoop projects that are coming up called TDE, or transparent data encryption, and Hortonworks is investing in that significantly in terms of resources as well. So we're very happy to see that. So you can take these storage level technologies and you can tie that into a more robust stateless key management and policy management solution to give you at least storage level protection in case of physical theft of those nodes. Now, in the short amount of time we have, so I wanted to cover some customer studies in the next 5 to 10 minutes as well. The first study that I wanted to cover is a global telecommunications company. So this company, as I said, is putting 17 sensitive data elements in Hadoop that they need for their business processing. So this includes things like names, social security numbers, phone numbers, email addresses, location information, etc., into Hadoop as well. Now, if you really think about it, a GPS location by itself is not a privacy issue. And a phone number by itself is not a privacy issue either, because you can look up anyone's phone number in the white pages. However, these two pieces of data combined is certainly a big privacy issue. Now, if I know where Peter was from a GPS perspective on Saturday, along with his phone number, then of course that is a huge privacy issue. So this organization essentially, was concerned that they were exposing, private data of their consumers when they put it into Hadoop. So now, from a business process, what these people do is that they take about 300 million records at a time with 17 pieces of sensitive data elements in these records and push that into Hadoop whenever they're refreshing data into their nodes. So what they essentially did was that they integrated using their MapReduce jobs, they integrated that with the Voltage APIs that do encryption of these data elements before they go into Hadoop. So these folks have a 500, they're a Hortonworks customer as well, so we're lucky enough to have them as a joint customer. They have a 500 node Hadoop deployment that they're extending to thousands of nodes. And what they saw from a performance perspective is that it would previously take them 90 seconds to do that ingestion, while integrating voltage encryption into the process only increased the amount by another 90 seconds. So they were extremely happy with the SLA that they were seeing even when they put encryption into the business process. And then, of course, Hadoop is just one environment. This customer has taken voltage tools and integrated that into a number of different systems, including Oracle, ZOS systems. They've included the native voltage tools on as well, and that's how they're doing their data processing in the Hadoop environment. I did talk a little bit about this healthcare insurance company. The healthcare insurance company is using Hadoop in 4 different ways, and all those 4 ways requires them to put sensitive information into Hadoop. So the first way is where they're trying to cut down on prescription fraud. So this is where, miscreants, criminals take prescriptions and they go from pharmacy to pharmacy very, very quickly, trying to refill them again and again. So now typically this took this healthcare company several days to unwrangle and figure out and prosecute people. But what they're trying to do with Hadoop is get, much faster access to whenever prescription Medicare fraud happens. The second use case is where they were looking to cut down on Medicare overpayments. So many times because of a business process issue, because of an error that they're seeing in their billing and payment systems, they found that they were overpaying, especially for Medicare treatments. So again, this took a lot of manual labor and many days to figure out in the past, but they wanted to deploy Hadoop so that they could do this in a very quick fashion as well. Now, the third use case is where this organization is investing heavily in their .com environment, so they could have more and more consumers come to their website, get up-to-date health information, and also very personal health information on the website, right? We're all seeing a big trend from healthcare insurers to give you more personal help, to give you more, very precise advice when it comes to websites as well. And that required for them to crunch vast amounts of data into Hadoop as well. And the other thing is, they have their monthly or bi-monthly developer hackathons where they would open Hadoop environment to developers and make them come up with, cool and new use cases to use Hadoop with. And for that, they needed a bunch of test data in their Hadoop ecosystems as well. So now all these 4 use cases required them to put sensitive patient information to Hadoop, which is, of course, a big no-no from a regulatory compliance perspective and from a security perspective as well. So essentially, they used the voltage tools to integrate into Scoop. So when this sensitive data was pulled from different upstream systems, it was encrypted and then stored into HDFS. And most of their querying and most of the success of these 4 use cases happened on protected data itself. The last slide I wanted to cover is that of a credit card organization, so a global financial services company. Now, this company is rapidly looking to invest in Hadoop because they want to reduce some of the costs that they face with storing data on data warehouses and also in RDBMS systems. So this includes things like, online fraud detection, marketing, collection agencies, etc., that they wanted to push into Hadoop as well. Now, a common use case for this customer is where they pulled data from different sources using commercial ETL tools and then stored that data on a landing zone. Then they would run the voltage tools to protect that data, to encrypt or tokenize that data if it was a credit card number, and then push that into the Hadoop ecosystem. So that way, they got the advantage of central key management and policy management that a product like Voltage provides, but could make sure that only the right people were given access to real credit card numbers if their analysis did require that. So this is a good example of how tokenization was used in the credit card world to take that system out of PCI audit scope. So I wanted to be sure that I'm leaving ample time for questions. So just in summary, we talked a little bit about why it is difficult to protect data as it's moving into Hadoop. This is because the developer community is evolving rapidly. This is because there are more and more types of data that are going into Hadoop, and the uses of the people who are accessing this data are quite significantly different as well. We also looked at how a data-centric model could give you a platform where you could move protection as close to your data elements as possible as well. So that way, your data could be protected in motion, in storage, and in use, which is what we're looking at with technologies like format-preserving encryption and stateless tokenization. And then we also looked at a couple of architectures that you have different interface points for protecting data before it goes into Hadoop, and also different interface points depending on your security and performance needs to decrypt that data only as it's needed by authorized people in your query sets. So Peter, hopefully that gave our audience a bit of information to process. I'll hand over the line to you, and let's make sure we spend some time on questions here as well.
What an incredible understatement, a bit of information. I feel like I've been sitting next to a fire hydrant trying to get a drink. That was amazing. Now, before we get to the questions, let me review with everybody how it's very easy. All you have to do is go on the interface on your PC where it says questions, click the button, type in your question, and we're going to try to get to as many as we possibly can. I also want to remind everybody that you will be receiving follow-up email from us tomorrow on how to access the archive version of today's presentation so you can review the information at your leisure and hopefully pass it along to your colleagues. Incredibly insightful session. With that said, let's see where we can start here. So the first question, and it's a toss-up, which is, can you clarify when you recommend using encryption versus when to use tokenization in Hadoop, or in general? That's a really good question, and maybe both of you can address the issue with, so who's got the keys, where are they, what about the security of the keys?
Yeah, I can talk to that a little bit, and then hopefully Balaji can add some color as well. So encryption and tokenization essentially take you to the same place, but they get there differently. So the aim of these technologies is to take your real data, replace it with a surrogate, I'll say, or fake data. So if that data gets stolen, it has no value to the attacker. But encryption gets there in the context of using a symmetric key to do that association, while tokenization gets there in the context of using a random lookup table to do that association. So the reason why someone would pick encryption over tokenization is more for regulatory compliance. For example, for reasons that I think, Peter, we would need an entire other hour session to go through, the PCI Council says that if data is tokenized within a system, and if that system has no access to real credit card numbers, then that system is completely out of PCI audit scope. So what we recommend is that if you're looking for PCI audit scope reduction for your Hadoop environment or for any other system, then go for tokenization. But
I guess the big concern here, and maybe it arises from the Target breach, and now the British Airways frequent flyer breach and all these other things is all of this sounds good in theory, but in practice, there's probably somebody at British Airways, and I hate to pick on them, who really thought that there wasn't data that was in the wild that was unprotected that was being used to try and develop a new customer loyalty program, for instance. I think that everybody's got a challenge in terms of, so how secure really is the data?
Exactly. And as you're also alluding, I think, Peter, encryption is just one part of your data protection strategy, right? Because as with any security mechanism that we see, it's about layers. So you have your perimeter systems like your firewalls, your access control mechanisms. Within there you have your authentication and authorization systems as you go in. Within that you have things like database monitoring or packet inspection. And then at the very core you can have a technology like encryption or tokenization to protect the very inner sanctum, which is the actual data itself. So it's all about layers. And it's all about giving multiple layers. So encryption is just one part of a data protection strategy as well.
Balaji, you wanted to add something?
I think Sudeep summed it up perfectly. So encryption and tokenization leads you to the same goal. There are compliance like PCI compliance mandates, like credit card numbers to be tokenized. So that's where the organization approved the strategy. But it all goes to the same goal of making the data unreadable, that if anybody is able to steal or get unauthorized access, you're protecting the data at that level. So we should not get bogged down on these semantics. We just look at the use case of what we need to protect and how do we get there.
Okay, so I'm not smart enough to know what this question is asking, but I'm sure you guys do. Do I need to modify any of my existing ETL code, and eventually to what extent?
That is actually a really good deployment level question, because I think the person asking the question is really thinking about, hey, I've bought into this encryption and tokenization stuff, now how do I really get it done, right? So most ETL tools that you see out there, including Informatica, IBM DataStage, Ab Initio, they provide some sort of a customized process where, custom transformations, for example, where you can make calls to an external API as part of setting data movement rules. So most APIs, including the Voltage APIs, only take 3 or 4 lines of code change to get that done. So one way is to build custom transforms and to very minorly modify your ETL process so data is getting encrypted or tokenized as it's moving into Hadoop or between different systems. The other option is that companies like Voltage also provide command line tools. So that way, you're not modifying your custom transforms to make API calls, but you're just calling an external script that can then run on a file or a flat file in your landing zone to get that process complete. So it's actually a very good deployment question that, yes, sometimes you would need to make 2 or 3 lines of code change to an existing custom transform, or other times you might just have to call an external script to get that processing done. So,
well, it goes to a higher level question actually, which is, IT administrators are always worried about pain points, especially with the introduction of new kinds of capabilities. Why don't you talk a little bit about, and Hortonworks is really right at the core of all this, about how the ease of implementation and how much this how much pain this might cause your organization.
So let me take a first step at that, and then Sudeep can obviously add in. The core part of what we do is making sure when we deploy Hadoop, we reduce the pain of adopting Hadoop. And a critical aspect of that is how it gets installed and then managed. So the operational aspect of administration over Hadoop it's been a core focus through Apache Ambari, and making sure that we can easily deploy applications, easily maintain, provision or deprovision on Hadoop, and also administer all services coming in and out of the system. So we have come a long way in terms of addressing and that part of. If you take just the security standpoint, again, that's the goal we want to achieve. We want to make sure we got consistent security, but we also want to make sure it's ease of use in terms of how it can be installed and how it can be managed. And working towards a set of all the ecosystem of partners. And Hadoop is not a monolithic software in an enterprise. It works in conjunction with a lot of ETL tools and other applications, other BI applications. So we really need to take a step back and make sure in a typical deployment, how do we deliver consistent experience. So we have done a couple of things on that aspect. The movement of data movement, if you take just the data movement and classification, we recently introduced the data governance initiative, where we are looking to build a standardized framework for getting data in, transform it, classify it, and put it in Hadoop. And based on hook points where you can introduce APIs for encryption and security, or you can introduce API for data discovery. But it's going towards building a standardized model around Hadoop and delivering a consistent experience. The other aspect is on the Open Data Initiative platform that Hortonworks has recently announced with other partners. It goes towards the same thing. However, can we deliver a standard set of tools and infrastructure to our customers so it's a very consistent experience? So there's going to be a lot of work in the next couple of years towards getting on goal, but the foundations has been set through already.
Okay, so Mickey's hands are getting toward the top of the hour. There are two priority questions that we have here that hopefully we can get through. So I don't want to put any pressure on either of you, but let's start with this one. What's the minimum size of the enterprise that can be implemented? Which is a really good question. Who should be worrying about this?
I can take a bit of a shot. Obviously, security is something that every enterprise that hosts sensitive data should be concerned with, right? So if a large bank or one of the largest banks in the world gets breached, the pain to them is significant. But even if a small retailer or a smaller payments processor gets breached, this can pretty much put them out of business as well. Right. So the technologies that Hortonworks provides and that Voltage provides in terms of security can be deployed by even the smallest organizations. So especially from a Voltage side, there is not much investment. There's a key management and policy management server that has to go in, and then there are some very simple integrations that you can do, either from a command line perspective or from an API perspective to protect that data. So I would actually say, and Balaji, curious about your thoughts, but I would actually say there is no minimum size to an enterprise who should be worried about security here.
I agree.
So Balaji, can I put it on my credit card?
Yes, absolutely.
Make sure it's tokenized first, Peter.
Exactly.
Yeah, absolutely. Okay, last question, and it's a good one, which is in Hadoop, how does encryption or tokenization provide more protection than HDFS encryption?
You want to take that, Sudeep?
Yeah, I can take a quick shot at that. Now, one of the things that we discussed is that not all encryption is the same, and the place where you deploy encryption or the layer in your stack where you deploy encryption pretty much decides the power that you get out of it, right? The use that you get out of it. So storage level encryption systems are great, but they only provide you with protection. They only provide you with protection because against physical theft, right? Because this is deployed at the driver level. And if someone walks into your data center and steals a node, or if you lose a disk, you're protected. But higher level technologies like field level encryption and tokenization give you protection across the stack, so that data elements are also protected against rogue admins or rogue users, because you're moving the protection closer to your data and as high up in your stack as possible as well. So Tim, I think hopefully that answers the questions for the team.
Yeah, I unfortunately, God, time flies when you're having fun. That's going to have to be a wrap. For anybody who asked a question that we didn't get to, I'm sure we will get it taken care of offline. First of all, I'd like to thank each of you for attending today's event, as well as Balaji and Sudeep and Hortonworks and Voltage for allowing them to share their insights with us. One last reminder, check your inbox tomorrow for additional information on how to access today's webinar so that you can review it at your leisure and pass it along to your friends and colleagues. And once again, we know you have very busy lives, and this was a very busy day. We appreciate the time you spent with us. Thanks again, and have a great day.
Thank you, Peter, and thank you, audience.
Thank you, everyone.